Hello students, in this video I am going to talk to you about estimating the amount of NaCl, KCl and MgCl2 in a given sample mixture by Argentometry titration. Okay, so the question at hand is a sample mix contains 10% weight by weight of MgCl2, 40% weight by weight of KCl and 50% weight by weight of NaCl. This sample is dissolved in distilled water and titrated with 0.1 molar AgNO3, and the liberated AgCl PPT was washed with distilled water and dried in an oven and was found to contain 1.4332 grams of AgCl. So we have to now estimate the individual weights of NaCl, KCl and MgCl2. Okay, so we have been told that the sample contains 50% weight by weight of NaCl, 40% weight by weight of KCl and 10% weight by weight of MgCl2. So if M1, M2 and M3 are the masses of NaCl, KCl and MgCl2 respectively in grams, we know that M1 by M3 will be 50% by 10%, which is fine. So M1 will be 5 times that of M3, and similarly M2 by M3 will be 40% by 10% is equal to 4. So M2 will be 4 times that of M3. Okay, so this relationship will be using later down in the calculations. Okay, so now we will be looking at the Argentometry titration. So we know that when the sample is dissolved in water and reacted with 0.1 molar AgNO3, all the KCl, NaCl, and MgCl will react as follows with the AgNO3. So NaCl will react with AgNO3 in a 1:1 molar ratio to give you 1 mole of AgCl. KCl will also react with AgNO3 in a 1:1 molar ratio to give you 1 molar of AgCl, whereas MgCl2 will react with 2 moles of AgNO3 to give you 2 moles of AgCl. Okay, so that's what to keep in mind. Okay, we are also told that the combined weight of AgCl PPT, okay, from all this NaCl, KCl and MgCl2 is 1.4332 grams, okay, which actually equates to 0.01 moles of AgCl, because molar mass of AgCl is 143.32 grams per mole. Okay, all right. So now let X be the number of moles of NaCl present in the sample, Y be the number of moles of KCl present in the sample, and Z be the number of moles of MgCl2 present in the sample. We know that X moles of NaCl will react with X moles of AgNO3 and gives you X moles of AgCl. Similarly, Y moles of KCl will give you Y moles of AgCl. But Z moles of MgCl2 will actually give you 2Z moles of AgCl, right? So because that's a stoichiometry, okay? So this means that the total number of moles of AgCl precipitated in terms of X, Y, and Z will be X plus Y plus 2Z. And this we have calculated as being 0.01 mole, okay? So now, when we do the calculation, we know that X plus Y plus 2Z is equal to 0.01 mole. Now we know that X is the mass of sodium chloride by its molar mass, okay? M1 by capital M1, where capital M1 of sodium chloride is 58.44 grams per mole, okay, grams per mole. And similarly, Y is the moles of potassium chloride also obtained in the same way, M2 by its molar mass, where M2, the capital M2 for potassium chloride is 74.55 grams per mole. Similarly, Z for, MgCl2 will be its mass M3 by its molar mass, where M3 of, the molar mass capital M3 of MgCl2 is 95.21 grams of gram per mole. Okay, so now what happens when we substitute for X and Y and Z in the equation? We get M1 by its molar mass, okay, of sodium chloride, M2 by molar mass of potassium chloride plus 2M3, okay, because it's 2Z there, so 2M3 by molar mass of magnesium chloride to be 0.01 mole. So we also know that earlier we established that M1 is equal to 5M3 and M2 is 4M3. So we are, now making this equation in terms of M3, okay, and reducing the variable to just 1, okay. So we can see that substituting for M1 and M2 in the equation, we get 5M3 by molar mass of sodium chloride plus 4M3 by molar mass of potassium chloride plus 2M3 by molar mass of magnesium chloride is equal to 0.01 mole. Okay, if we do the mathematical jugglery in the terms, we get molar mass, okay, we get M3 equal to, we get M3, the mass of magnesium chloride is equal to 0.01 into molar mass of NaCl, molar mass of KCl, molar mass of magnesium chloride, the whole thing divided by 5 M2 M3 plus 4 M1 M3 plus 2 M1 M2, these are the molar masses. Okay, so this term, okay, now substituting, for all these values, okay, we do the calculation, we get the mass of magnesium chloride M3 as 0.0624 grams. So which means the weight of KCl in the sample will be 4 times that, which will be 0.2496 grams, and weight of NaCl in the sample, okay, which will be 5 times that of MgCl2, which will be 0.3120 grams. Okay, so the weight of NaCl in the sample is 0.3120 0.20 grams, KCl 0.2496 grams, and MgCl2 in the sample will be 0.0624 grams. Thank you.